Now, with that said, I want to introduce our first speaker in the second half of the day here, Scott Alt at Kite Pharma. He is a CMMS. He's presenting on CMMS maintenance reliability. He is a maintenance coordinator at Kite Pharma. He works at the Frederick, Maryland site. He has a diploma in maintenance and reliability management from NC State University. He studied industrial maintenance and industrial controls, and he has 25 years of experience in industrial maintenance, including roles as technician, planner, coordinator, and shift lead and manager. So welcome, Scott. You should have all the access you need to share your screen.
Nope, it says it's disabled.
Oh, we don't want that to happen. All right, now you should have access to do that.
There we go.
Well, welcome, though. We appreciate you presenting today. Scott has presented at previous summits.
So can you see my screen? Well, it's one of the famous Zoom questions. Are you able to see my screen?
Looks good from my end.
Okay. So that's the biggest question on a Zoom meeting. I think that's the 2020's new motto there is you're on mute, or can you see my screen? So welcome everyone. I'm going to talk a little bit about CMMS maintenance reliability. My presentation this year is a little different. This presentation is not Blue Mountain specific. These items in this presentation applies to reliability in all industries. Of course, we're all at the Blue Mountain Summit, so we have compliance regulations we have to deal with too. But reliability is definitely something that everyone needs to pay attention to with their equipment. So this is a little disclaimer. This presentation was prepared by me in a personal capacity. The opinions expressed in this presentation are my own and do not reflect the view of Kite. There's my background. Drexel talked a little bit. I had 15 years of experience working for DuPont, chemical industry. I started out in production. Moved up through into the engineering department and maintenance, industrial controls, where I was also a shift resource and a shift operations manager for the maintenance department. Then I moved on to Thermo Fisher, where I got introduced to Blue Mountain. I started off there as an industrial controls technician and then moved into the lead planner and Blue Mountain RAM subject matter expert. Working with my friends over there. I see Gary Leitner on there and Tamara. Good to see you all. And then I did a short stint, I didn't put it in here, in the gas and oil industry as a planner for TC Energy, and now I'm at Kite Pharma. Glad to be there, great people. Glad to be working with them. Also have a diploma from North Carolina State in maintenance reliability management, certified industrial controls technician, and I went through a multi-craft internship with DuPont. Also a small business owner. I had a residential cleaning pressure washing business where reliability is really important when you own the equipment and you depend on it every day. So here's a little bit about Kite. It was founded in 2009 as a pioneer in cell therapy research. Kite's leadership position in the immuno-oncology space was solidified with our research and development agreement with the National Cancer Institute in 2012. And when the commercial manufacturing site opened in El Segundo in 2016. Since our acquisition by biopharm leader Gilead Science in October of 2017, our combined strengths has accelerated the advancement of our pipeline, including the launch of Yescarta, and has expanded the impact of our strategic partnership. This is a little bit how our Kite technology works. Our cell therapy uses the power of the person's own immune system to target and attack the tumors. This is accomplished through the use of genetically modified T cells that can increase the number of tumor-specific T cells and strengthen the body's ability to kill certain cancer cells. This is sort of like a pictorial here of how it works. And our mission is at Kite, we're focused on the cure. Our singular focus is on cell therapy and the use of genetically modified immunocells programmed to target tumors, which we believe has the potential to change the way cancer is treated. Through our focused efforts and important industry and academic partnerships, we have been able to advance our industry-leading pipeline of CAR T therapies. So, I always start off every presentation or meeting with safety. And we should all do this. A part of reliability is having safe equipment or approaching safety as we approach everything. So no matter what we do with safety, your CMMS can be used for more than just regulatory compliance and reliability. It also uses it to document safety. Use the tools in your CMMS. Put notes on work plan templates for safety items. Document the safety items on work orders when they kick out. Just remember, everyone come to work in a certain conditions. Let them go home in better condition than they came to work. Just make sure you add safety to everything you do, no matter what. I have a few questions for you, and you can send some answers there in the chat. If somebody can help me, maybe Savannah. I'm not able to see the chat. Don't know why. But I got some questions I'd like to throw out there. What is the simplest element to any reliability program? We'll give that a second and see if we can come up with some any comments or any. Drexel, maybe you can help me for some reason.
I'll keep an eye on it for you.
Yeah. So what is
the first person said common sense.
That's true. That's true.
We have a couple more. We have routine maintenance, usability, data and faith, and integrity.
Very true. Very good. Okay.
Operator feedback is another one.
That's very important.
Solid procedures and distancing are two more.
All right, I got another question for you. Why do we document data in our CMMS?
Compliance.
Very good. That's kind of a twofold question. We'll talk about that. What is our goals? It could be regulatory compliance. It could be a scheduling tool. It could be reliability.
And we have a couple more too coming in. We have trending, clarity and organization, recording all information, everything we do to the equipment, uptime, traceability. And they said so that it can be analyzed and acted upon.
Very great. And one more question, and we'll get in this. What is maintenance reliability? What's that mean to you?
First answer is trust in the equipment. No unplanned downtime, trust in their processes, uptime, trust in their people, availability, and no unplanned maintenance.
All good answers. All good answers. I'm going to give you the generic definition of maintenance reliability. Of course, in the dictionary, the ability of an asset to perform its intended function under a stated set of conditions for a stated period of time. Of course, all your answers are correct, and this is just the definition out of the dictionary. Why is maintenance reliability important to an organization? Repeatability. Repeatability is directly related to quality. If you can consistently produce the same result, it is easier to control the process. Have you ever had a piece of equipment that just did not run well? You could not get the same result out of it. You could not get it to repeat the same thing over and over again. That's a problem. That creates a lot of issues. It makes people not want to run the equipment. It shows up as poor quality. And in our industry, you know, our number one goal is to our customer and to make sure they get a product that is of the highest quality. So repeatability is a really, really important focus for us. Customer satisfaction. Poor running equipment lowers morale and confidence in the maintenance department. You know, if you have a piece of equipment, just like I said, that runs very poor, no one wants to run it. Everybody complains about it. People have a bad attitude about that piece of equipment. So it's very important. Reliability is directly affected by the customer satisfaction of the equipment. Reputation. You know, if you don't have reliability and you have poor running equipment, it can create a bad reputation for not only internal customers, but external customers. You're putting out bad product and it's getting out to the field. You know, in our industry, that's not good. That's very poor. It's not like we're making widgets that people buy that they're just using for anything. You know, this is medications. This is, you know, things that need to be perfect the first time. And then we get into the cost part of it. So controlling operation and maintenance costs, budgets are much easier to maintain with reliable equipment. Production schedules can be made and the costs can be projected. So if you've got good, reliable equipment, you can predict what the cost of that equipment is to run. And you can also you can schedule by it. Competitive advantage. Hey, if you got a really good piece, if your reliability is high and you got good running equipment, it gives you a competitive edge. You know, you can produce it better and faster than anyone else. So reliability plays a significant role in all this. So what does reliability look like? This is a simple bathtub curve. So as you see here, reliability, when you put in a new piece of equipment, usually, this is sort of the curve you hit whenever the reliability curve. So in the beginning, you're going to have some failures. You're going to have some items that don't work right. You're going to have things that aren't adjusted correctly. And then you have this. This is when the equipment is very reliable. It's running right. There's no bugs. You've worked all the bugs out of it. This is when you can predict the cost, the reliability. Near the end of the life of an asset, you'll start seeing an upturn in failures. You'll start seeing more work orders. You'll start seeing that your PMs need to change. You need to do things more frequently. A lot of companies use this bathtub curve. They can actually predict when an equipment needs replaced by using this type of chart. They'll actually put a number. They'll put a number on failures that at this point we're going to replace this piece of equipment. So this is sort of like a pictorial of what maintenance reliability looks like. There's elements to a maintenance reliability. Again, this is very high level. Maintenance reliability is a very deep subject. It takes years and years and years to understand and deep dive into it. This is a very high level, just an understanding of how maintenance reliability, and I'm going to tie in your CMMS to this near the end. So I just wanted to be clear, this is how maintenance reliability works. This is just a really high overview for people in our situation, what we kind of need to look at when it comes to assets, equipment reliability, things like that. So there are three elements to maintenance reliability. There's the inherent reliability of the equipment, there's operating environment, and there's maintenance. All of them are equally important. When should each of these elements be considered? If you don't mind, throw it in chat. When do you think these should be considered?
All the time.
Exactly. So actually all the time, but especially before you purchase the asset, you should be looking at, when you think you need a piece of equipment, you should do a specification on that piece of equipment and take all this into consideration. I got a couple examples here when something wasn't taken into consideration. And sometimes in industry, we need the specific piece of equipment. So some things you have to live with. But I always give the example of when it wasn't taken into consideration is, anybody know what a video jet is? A video jet is a piece of equipment that uses ink to jet a barcode or a date on a can or a package. So I worked at a place that had these video jets, and they seemed to work perfect. We put them in the summertime. They worked perfect. Then we got into the fall. You know, about this time of year, you'll start seeing the temperatures dip down to about 30, 40 degrees at night. And in the daytime, it goes back up to 70 and 80. Due diligence wasn't done when we bought these because we also didn't have a controlled environment in our production area. So the production area would also get down to 40 degrees at night and 80, 90 during the day. We didn't take it into consideration. So what would happen is every morning at 6 a.m., we were having to go out to these video jets because the temperature directly affected the ink in the units. So we didn't take into consideration up front the temperature. So we had equipment now we had to deal with. So now we had to do modifications to the equipment so that we didn't have these issues. So all these elements are very important and they need to be thought about up front. Now, I'm not saying you're going to get everything, but you should have some sort of formalized process that takes you through looking at each of these before equipment is purchased. Has anybody ever had an asset delivered to their site and didn't even know it was coming? And all of a sudden you're scrambling to trying to figure out, how does it operate? Who's going to operate it? What maintenance we're going to do on this? Who's going to do the maintenance on this? That just goes to the point. All this should be considered at all times. There should be a formalized process up front to determine these things. Each one of these elements are intertwined. Each one can affect the other one. So just keep all of these in mind. So we're going to talk a little bit about inherent reliability. And what is inherent reliability? Inherent reliability is the design robustness of a system or piece of equipment. It provides an upper limit to the reliability and availability it can be achieved. So in other terms,
Rihanna,
how it's designed.
one that you gave me.
This is how the equipment is built, how it is bought. So this comes, is it a piece of equipment that was spec'd out, or is it an off-the-shelf piece of equipment?
That's why I wanted you.
You need to specify this in ahead of time, if you can.
No.
And I'll just have a question. I'll throw this out here, and it'll be another chat question.
But not yet.
Can the inherent reliability of an asset be improved? What do you all think?
My life is over.
Getting any responses,
It
Savannah?
depends if you're the salesperson or not. Well, what happens is people don't know how to read the specs of their equipment when they're buying it. So they always look for the best spec. You know, like you look for a standard, for example. Some have 30-day specs, 90-day specs, even 24-hour specs, and 1-year specs. So they're buying something that, unless they calibrate it like every day or every 30 days, they're not going to achieve what they want.
Right. So As far as inherent reliability, can the inherent reliability of an asset be improved? This is a trick question. Yes and no. The only way to increase the inherent reliability is by redesign or modification. And we all know what that is in our industry. An asset can only be as reliable as it's built. The asset will never be more reliable than it is designed. You can't make an asset by PMing it better than it is the way it's built. It's only going to be as efficient and reliable as it is built. Operating conditions. Operating conditions is the condition which the asset has to operate and how the asset is operated. So this includes environmental conditions that the asset is in. Is it in the right temperature? Is it in the right cleanliness? I mean, is it have a certain air quality that's needed? Also, operators' training and skills. Are the operators should be the first line of defense in monitoring assets performance. So if you have a really good trained operator, that's a plus for you. If your operators are not up to snuff or up to speed, that's part of the operating condition. That can be an issue for you. So operating conditions is an important element. This operating condition is basically it's how it's operating. Here's an interesting fact I found in a book I was reading. Several studies have indicated that 40% or more of failures are the results of operational errors. That to me was a crazy number. Like, what would it be like if you went to your management team, your operations manager, and said you could increase the efficiency of a piece of equipment by 40% just by having good trained operators and by having it set in the right conditions? That to me was a crazy number. Maintenance plan. The objective of a good maintenance plan is to sustain the inherent reliability of the asset. There's different parts of this is pretty much how it's maintained. This includes operator-based maintenance, preventative maintenance, predictive maintenance, which we're going to hear about, I think, tomorrow. We have some predictive maintenance, and actually run to failure. Run to failure is actually a legitimate maintenance plan. I can give you an example. Years ago, I had a vacuum pump that the vanes would go bad on constantly. And of course, me being a young mechanic, I'd run out there, tear it off the machine, put new vanes in it, put it back in. I did a great job. I fixed that piece of equipment right up. I had a reliability engineer stop by my workstation. He's like, "What are you doing?" I'm like, "I'm rebuilding this vacuum pump." "Why?" "Well, it's broke, it needs fixed." And he sat down and explained to me, that vacuum pump costs $200. So we keep them on the shelf. For you to repair that vacuum pump costs us $400 because you got to buy the rebuild kit and then your time and effort to take it apart, put it back together. So by you repairing that vacuum pump, we're in the whole $200, which really opened my eyes up to that was crazy to me. Don't you want to fix things and put it back in? It can actually cost you more money. So run to failure is a legitimate a maintenance plan. Then we got corrective maintenance. I'm sorry, let's go back here. So we got the element maintenance plan, you got autonomous maintenance, you got preventive maintenance, you got predictive maintenance, you got run to failure, you got reliability centered maintenance, and you've got corrective maintenance. Your corrective maintenance is your repairs. That is your on-demand work. That is your, hey, this is broke, come out and fix it. You need to document that. That is very important information for reliability. Repairs and breakdowns, document every time. Every time you observe a piece of equipment, document it. This is key. It's also important to kind of do a root cause analysis on each work order for corrective maintenance. What is the CMMS role in maintenance reliability? So what do you all think? What is the role of the CMMS in maintenance reliability?
We have repairs should not be documented on a PM. This impacts trending.
Very correct. That's a very good answer. So we're going to talk a little bit. What is the role of CMMS in maintenance reliability? We're going to go through each one of those now. Inherent reliability. So when you document items in Blue Mountain, you should put all that data in Blue Mountain. Your PM should be documented. Your conditions should be documented. Your repairs should be documented. When you do that, what it tells you is, did you buy the right equipment? You can look at your work order metrics and your trends to tell you if you purchased the correct equipment. If the equipment is fit for what you purchased it for. So that's how your CMMS works with inherent reliability, or how it helps with inherent reliability. Operating conditions. Your on-demand work orders really tell you if you're operating that in the correct. Is the equipment fit to be operated in the environment it's installed? Are the operators skilled to have the level where they should be? Is the equipment too complex to operate? It's very important to use failure codes in the CMMS. I suggest using the data tree on all your work orders. I don't know if many of you use that, but you should do a small root cause analysis on every on-demand work order to tell you, was it failure? Was it operator? You know, was it man, human? What was the issue? All that data gives you information to do metrics. And then by using that information in your metrics, you can help make improvements. Maintenance plan. By documenting everything in your CMMS, you can tell if your maintenance plan is working. There should be a regular scheduled review of all your maintenance plans. You should look at all your on-demand work and then see if you're doing the right PMs. Are you doing them on the right schedule? Are you doing the right things? Your actual CMMS will tell you that if you're documenting all your information. You can't over PM an asset. You can't over grease. You know that. You can fling grease all over. So all that's important. So back to the question, what is the simplest element to any reliability program? This is extremely important. Every time an asset is observed or touched by maintenance, it should be documented. This is your reliability data. So every on-demand work order should have a root cause performed. Make it basic and use the data tree in Blue Mountain. Documentation is your metrics. Continuously run metrics. Metrics indicates the health of your organization. So I would say the most simple element in any reliability program is documentation in your CMMS. If your CMMS is not set up for you correctly, you need to get it set up for you to get the data you need. Blue Mountain is extremely configurable to your needs. Use that to get the information to give to reliability. Reliability to me is just as important as, of course, we got to be compliant, but reliability of your assets and your assets being available for use is very important, because you have an obligation to your customers to make sure you give them good quality product. So why do we document in our CMMS? It gives us our leading and lagging indicators in your CMMS. That way you have a baseline of where you start from. So basically, in closing, I guess I always see this term, and it really means a lot. If it can be measured, it can be managed. So basically, start measuring your information coming out of Blue Mountain. Start running metrics. Start somewhere. Create a baseline. go ahead and create your, get your failure codes. Why are you doing on-demand work? Measure it. And then once you measure it and look at it, then you can make changes to manage it. And thank you. So I'm not able to see. Is there any questions?
Thank you, Scott, very much. We'll give a few minutes here while people write in some questions. Certainly lots of comments for you, just as you asked for kind of throughout your presentation, but let's just give it a few minutes here. So the first question is, Scott, how many discrepancies or failures of an equipment at the end of the bathtub life cycle do you usually see in the industry that leads to decommissioning equipment?
That based on the actual industry you're in. That's a company question. I've seen companies not even care. They just keep running it. I've seen some companies set an actual dollar figure that says, after I hit this much money in repairs or this much money in lost time, I'm going to replace it. That's kind of just like a company decision.
Thank you. There's another comment here that says, good job, Scott.
Thank you.
On the best practices template, why do PCR codes on PM work records and not gen work records? Corrective. I don't know, Dennis, if you want to unmute yourself and maybe elaborate a little.
I think I understand this question, Drex. Or go ahead, Dennis.
Yeah, just so a couple places that I've worked with Blue Mountain, it seems the PCR codes, the problem cause remedy codes, show up on the PM. And what Scott's saying here is that it sounds like that really needs to be on the general work record, correct, Scott? Other than the PM, it kind of makes sense to me. I was just wondering the logic behind that.
Yeah.
So to answer that, the maintenance work order represents both corrective and preventative. Based on the fields or how it's generated, determines if the maintenance work order is preventative or if it is corrective. Normally, when we discuss when I discuss general work orders with customers, general was intended to capture activities that don't necessarily fall under the maintenance category, nor do they fall under the calibration category. A common example might be like pest control, if you have to replace pest control traps throughout the facility. But I have seen some places will use a general work order to represent a corrective. That's up to you guys to decide. But originally, maintenance work orders were supposed to capture both preventative and corrective. Is just whenever I create it from a schedule, it has the event ID, event name, and whenever it's created on demand or manually, that's absent, and instead it says on demand. That's generally understood to be corrective as well. Also, type of service can be used to determine corrective or preventative.
So I'd like to add to that, Nick. I agree with you 100%. Right? If you're doing corrective work and it's calibration, it's a calibration work order. If you're doing corrective work and it's maintenance, what I've seen in the past, general work is exactly what you're talking about. Things like fire extinguisher checks. You know, it's kind of that general site work that's done that you're using it for. But it is, again, if it's calibration work, whether it's corrective or it's scheduled, it's still calibration work. That's where you're delineating it with the on-demand. Agreed.
I would agree with the calibration work. I just, I've seen a lot of places have been workflows are set up that technicians will generate an on-demand general work, and it doesn't capture that. So I guess
that can be added, Dennis.
Pardon?
Oh, sorry. I didn't mean to interrupt you. I'm sorry. They can be added to the general work. It's just in the template. We didn't really foresee customers using it that way, but it can be added to the general work order.
Okay. I have to go back and look at that. Thank you.
Hey, Chris Tizzy, you brought up a good point. I'm reading through here. I couldn't see them while I was just, on display, but repairs should not be documented on a PM. That's true. If you're doing a PM and that's a mistake a lot of people make. If you're doing a PM, that's for the PM. If something is found during that PM, you should create a follow-up work request to capture that repair. The PM is just like an inspection, or look for this, do this, measure this. Any repair should be made on a repair, whatever you're using, a gen or an on-demand, we'll just say an on-demand, an on-demand work order to capture that so that you can run the metrics. Also, you know, it needs to be separated. PM tasks should be separate from repair tasks.
And Scott, to chime into that, right? So I also like to see codes so that in that, I'll say, follow-up work order, it's corrective from PM, right? That's helping you understand how effective your PMs are. And then you can then look at all the correctives from PMs on a particular type of asset and say, okay, do I need to update some of my PMs based on age of the equipment, et cetera? And that's where that trending and the data, historical data, comes in to help you develop your program and you know, add some maturity to it.
Yeah, and that's a good point too. Just because you put a PM on something when it's brand new, that PM will change. When that equipment's 5 years old, you might have to tweak it. You know, when it gets 10 years old, you might have to do it more often, because you're getting to that point where you're trying to, that bathtub curve, you're trying to keep that bottom as long as you can. Sometimes that is doing a rebuild on it. Sometimes that is making your PMs more often. Sometimes it's adding items to the PM. But most companies, you know, they want to keep that piece of equipment running as long as possible, because there comes a break-even point, and then there comes a profit point. You want to increase that profit point as long as you can. It's like taking care of your car, you know. If you do the things you're supposed to do, it'll keep running. You know what I'm saying? But if you don't change the oil in it, and you don't rotate the tires, and you don't change the timing belt, it's going to break on you. You know, it's just the way it is. So good point. I appreciate the help on that.
And Scott, just one other item to your comment earlier around whether you call it RCM, total productive maintenance, but getting the production people involved, right? I added a comment to chat. If you bring your car to the mechanic and you can't tell him what's wrong or what it's not doing, he can't fix it. Right. So the best eyes and ears are the operators who are working the equipment. They're going to hear the anomaly sounds, the atypical sounds of what's going on with the equipment, the odd vibrations. They're your best eyes and ears in the field.
Yeah. And Chris, that's a really good point, because back when I was in the chemical industry, you know, when I was in the field as a controls tech, they called me out to line and say, machine's not running right. What do you mean it's running fine? You're running 80 cans a minute. Like, don't you hear that? No, I don't. What do you mean? But operator that's run on that line for a long time, they can hear every tick, every whistle, every whine, and they know their equipment. So they might not be able to tell you what is wrong with it, but they can tell you it's making that ticking noise. You know that ticking noise? You know, a lot of times they can't tell you exactly what it is, but they can tell you something's wrong with it.
There's another statement here, and certainly lots of comments to the topics that you've had, but Peter says recently had a failure of lab analyzer, created on-demand work, which also initiated a change control due to the complexity of the repairs. Entered the as found equal to yes, as left equal to pass, but was overrolled. My thinking is we aren't true to the asset history. Thoughts?
Can you repeat that?
This is specific to calibration as well, I believe.
So my follow-up question for Peter would be, Peter, do you believe the as found should not be yes because it was a failure which then generated this on demand?
My thinking is there's no way it would have passed calibration. It just failed on its initiation startup. My thinking is we should at least identify this as a failure up front. And even the supporting documentation from the contractor even stated so. So we have all the supporting documents saying it was out of service, subsequently repaired. We should match that work history up. If we make as found equal no, we're not being true. We're not identifying that at some point this asset did have a failing event.
So that's, Peter, Chris Tenza, that's something that I would say I would sit down with my QA group and explain, because I agree 100% with you, right? As found is truly as found data. You walk up to the equipment as if the operator was about to use it, and we calibrate. And we obtain our as found data. It's not, if it's not within tolerance, as found data tolerance is a yes, very simply. If you can't obtain data, it's a yes. That's it. We provide data. The explanation is, well, yeah, there's a repair that needed, and we may do the repair and it passes calibration. That's your as left, understood. But you're absolutely correct. I agree 100%.
Thanks, Chris and Scott. Now, you both will be joining our after-hours networking event, right?
Yeah.
And that would be, I think we need to keep it moving to our next presentation here, but I certainly love the questions, and this will be a great place to continue it in our general kind of networking event with both Scott and Chris there. So, but thank you very much, Scott. We really appreciate you taking the time to present and joining us at this year's summit. And we hope we can present in person at some point too.